See, with the LCC, what we have been doing over the last couple of months is we have used the LCC to make various kinds of building materials, practical building materials which are used in all houses, like hollow concrete blocks, both non-reinforced and both reinforced. And we have been using this in making a building. So both as the beams and the columns, and with the different kind of building materials that we have produced, we have used this. In producing this kind of materials, what we have compared it with the normal kind of cement and with the special kind of cement, we have found no differences. So in terms of productivity of the materials, there is no difference. It's more or less, not more or less, it's absolutely the same. In terms of product quality, it's at par. Because you don't need to train up people even for using it. There is one of the major issues will be if I had produced a cement which has different properties than the normal cement, then it would have been difficult to convince the industry to use it. But since it is same or similar, you only need to, even what cement companies are talking about is they can place it as a special kind of cement based on the economics part of it. But no real training is required for its use or for its application use, nothing. See, standardization in India, it will be based on the technical parameters. Now, if the durability, and all other parameters of producing a cement or use of this cement is okay, then I don't see any problems of standardization process of it, because we have done it quite a number of times, and we have seen there is a fixed standardization process or parameters in our Indian codes. So there will not be any issues on that. This type of blended cements has been in use over the last, if you see Indian palaces, last thousands of years ago, historically, they have been using combinations of lime and pozzolanic materials. Similar to kind of, at that time even cement was not there. Huge kind of stones, the buildings are still there. It is similar kind of cement. 20 years ago, we had been using this kind of pozzolanic cements, but due to standardization processes or lack of standards, there was wide variation. And people were adopting some other means of producing this cement, so it was not a very popular material. But with the kind of studies that we are doing now, because previously 20 years ago, it was a little bit unorganized also. Now with the kind of scientific knowledge that we have and the scientific rigor that we are bringing into this cement, it will be, we now know everything, what happens with this cement. So that will be a quite a good kind of and process of introducing any newer kind of materials. The basic value that we see in India is scientific knowledge. There are 3 partners who are there. Each of the partners has the positive influence that they are bringing into this whole network. Well, EPFL brings in the scientific rigor into it. India brings it the scientific knowledge also, and the application oriented part of it. We are applying it into the field, and this kind of field kind of application is going on and feeding it into the research part, where the research is also strengthened and the application part is also strengthened. Compared to the normal cement, we are now, our target is the existing cement plants. So if with the existing cement plants, if I have to use a calcined clay is, calcination temperature will be something around 800 to 850 degrees centigrade depending upon the clay. Now to do this, a cement plant can do this in 2 ways. Number one, they have these rotary furnaces where they make clinkers. At 1450 degrees centigrade, you generate a lot of waste heat. So, and the waste heat temperatures go up to around 900 degrees centigrade. So if we can use those waste heat in building up a similar kind of calciner, of calcining this clay, then you don't need any extra additional energy. The only investment that you need is a rotary calciner, which is of not very high cost. Looking at the fact that you will be reducing your clinker percent. Clinker, so instead of firing it at 1450, now you are firing it at 800 degrees. This is, a lot of people are thinking of using these. Now, second scenario will be where a lot of cement plants are using up those waste heats also through the existing processes. They only need to invest on the rotary calciner. So, but that is also of not very high cost. There are, if I analyze a kind of cost benefit of installing a new plant, new rotary calciner additional to this, it is of not a huge investment.